Hello there. Welcome to another session of Chill and Chat, brought to you in part by me. So, it's only my second, third, maybe my fourth Chill and Chat session. So hopefully we'll see who joins us today. I do have a few things I want to talk about. I want to thank Rich, who I believe posted this on Facebook and Twitter real quick to get this out there. But a couple topics I want to talk about today are differences between some of the different Voron printers, differences between printers in general. I also want to talk a little bit about differences in ASA and ABS because it seems to be a topic that a lot of people are breaching these days. I also want to talk about polycarbonate filament. I have a little bit of experience with that. A lot of people seem not to. And outside of that, I just want to chill and chat, see what people are up to, see if there's questions about my current build, see if there are questions about what's going on in my life, or maybe there's things going on in your life that you want to talk about, or your printing life, should we say. So with that, let's see here. You have an echo going on. All right, let's see. Echo. It should not be an echo. Echo. Echo going on right now. Nope, it was just me. Okay. People. There is no echo. Perfect. Chuck, how are you? Nice to see you here. Let me check one more thing here before we get too far into things. There we go. Let me see if I can get my stream up with the chat on the side real quick here. People like that on the replay. Stand by. Maybe chat. Let's see. Something like that. There we go. Much better. So first and foremost, since I got the reminder down below me, I want to give a special thanks to the folks that are down along this line right here. Nothing against people that aren't doing this, but as part of my Patreon support page, I tell these, or people that do support me on Patreon, that I will put their names on my videos and kind of give them a shout out as a thank you. And I do have a couple extra people down there, namely, oh, that way, we just missed them, but the First Layer, DeWitt 3D, Golden Jaguar, all a big help, both in my 3D printing life as well as my YouTube life. So special thanks to all those people. Special thanks to Mark Davis, SK3D, Brad Nora. Brad is the super fan out there. He is the one that decided that while his wife was in labor, he was going to be the first person to post a comment on one of my videos. So I just want his child to know in about, I don't know, 10 years or so that your dad did that. So there you go. Let's see here. We have Chuck, we have Rich from the First Layer, we have Stephen Reamer. Chuck I've been talking to recently via email, which is great. Again, my email, kerm@builditbasement.com, in case you want to reach me. It is on my YouTube page if you want to go there. By all means, leave me a comment or send me something in any of my videos there. But if you do want to send me something more long form, email works quite well for that. But Chuck has been working through some issues with his tap. He had a crash and he completely lost his tap. So he's rebuilt now. He sent me a picture this morning of a calibration cube. And Chuck, I'm gonna drag you out a little bit here, but it's just for good sense. You get a sense of somebody with these videos and things like that. But so Chuck sent me a photo, and I'm gonna see if I can bring this photo up. Let's see here, bring it over here. I gotta remember to breathe when I'm doing these videos. I'm still really new to this. So let's see here. Do I have yep, we got this one right here. So he sent me this photo right here of a calibration cube. It looks like the Voron calibration cube based on the locked edges. And it looks pretty damn decent to me. It looks like a semi-translucent PLA or ABS. I'm guessing ABS. But First Layer looks decent. No issues there. But the funny thing about this whole thing was, and let me get back to the right window here. I haven't adjusted on my windows yet. Let's see here, maybe chat. Is Chuck was off on his print a hair. And when I say a hair, I mean less than a hair. So Chuck basically wrote in and asked me about adjusting his X and Y. His cube measures 29.96 by 30.02 on the Y. Chuck, your cube's good, buddy. I mean, yeah, you can fine tune that, but like I wrote to you in your email, if you haven't seen it yet, when you get down to those, you know, tenth of a human hair differences, you're going to be whittling out your returns on investment and time to whittle those down are not going to be suited. And the reason for it is because you're going to have different types of filaments. I mean, heck, if your extrusion is off ever so slightly, if your filament, you know, 1.75 filaments, 1.72, 1.74, 1.76, you're going to get little things like that that happen in your print. You know, it's one of those things where you're down to a finite point now. I mean, I would let's see, 29.96 on your X and 30.02 on your Y is nothing to complain about. Trust me on that. And I think there's a bunch of other folks on here right now that would agree with that. Let's see here. Golden Jaguar joined along. Hi-yo, folks. Hey-yo, folks. Hey, how we doing, Golden Jaguar? How's Florida today? Hopefully it's warm. Let's see here. Good, good, good. So anyways, I just want to touch on that one real quick since Chuck is here and I saw him. Brad's not here. Brad's been having issues with a bunch of different things, including his belting. Just on a quick one on that one while we're at it. Let's see if this camera, my fat head's in the way. On these belts, if Brad checks this out later or if he shows up today, Brad watched a video where an individual told him to pull these belts as tight as possible. Don't. Just don't. I mean, you're pulling tension against plastic here, Brad. Do not pull these overly tight. They should have some flex in them. The only thing you gain by pulling your belts tight is more wear on your stepper motors and probably a loss of speed. You get to a certain point, and if you're not skipping your teeth on your stepper drivers or your idlers, you're good. You don't need to be tighter than that. In terms of holding place and things like that, again, if you're not skipping teeth, your Z or your Z will not move. And if it does go up and down when your printer's turned off, that's going to be normal for your printer. It all depends on your steppers. If it's turned on and they move up and down, you might want to adjust the current going to those steppers in the hold position. So let's see here. Firstly, again, hey again, Richard. Oh, I guess you guys were together. You know, Tim's not going to show up. Tim's at the mall. Let's do it 3D. Well, that's fine. Tim's got better things to do to hang out with me. All right, let me get up my screen here. Talk about some other things I had on my mind, I should say. Where is my screen? Did I lose it? I may have lost it. Oh, there it is. There we go. All right. Let's see here. Woody just made it in. Woody is, I would say, a fan of the channel. I am a fan of Woody. Woody has been building a Voron 2.4, much the same as this one I have right here. And let me switch back to a camera where I'm not so wide so I can say hello to everybody. But Woody's been building his Voron 2.4. He's actually leapfrogged against this frog and now has a complete built Voron 2.4. I think he should try doing it on video. Woody has leapfrogged me and he's very impressed with his build so far, and I am very impressed with his. Maybe I'll show a picture of his a little bit later. Woody's also just getting over a bout of the flu, so congratulations and well wishes for Woody on that. I haven't seen Brad yet, but we all mentioned Brad. If you see Brad show up and say hey or something, tell him he's late. Yeah. So, quickly, one of the things that people have been talking about, or at least people in my little group, Yahoo bye flu, yep, is ASA, and there are mixed feelings on ASA. A lot of people have been talking about ASA as being equally easy to print as ABS. And ASA does look very, very, very much like ABS. Well, all filaments look alike, right, when they're in the package. But I will tell you from my experience, if you're considering printing ASA, one is make sure you buy a decent ASA, just like if you're buying a decent ABS. PLA seems to be like there's more variance out there in terms of quality versus what you get and cost. So PLA I wouldn't be so picky about. It's kind of like the de facto print filament. But specifically your ASA, your ABS, and in a moment we'll talk about PC. ASA to me, or my suggestion if you are trying to print ASA, is make sure you pre-wash your bed anew. If you've been printing with ABS or anything else that's on your bed, take your bed off, bring it up to the kitchen sink or the bathroom sink, if you got that big of a bathroom sink, and put a little Dawn dish detergent on there or whatever you use. Sometimes I'll even use very lightly now, a little Scotch-Brite pad. I cut them up like that. And just give your bed a little scrub. Get some of that other contaminant material off of there. Especially if you're somebody that always prints with ABS and now you want to switch over to printing a little bit of ASA. It's a good idea to get that cleaned off before you start doing that. Once you get that done, dry it off, use some ISO. I keep ISO in a spray bottle. It works pretty well. Clear your bed 100%. Printing temperatures for ASA versus ABS, I would raise your bed temperature by at least 5 and probably 10 degrees. And then on your hot end, I would again go up probably 5 to 10 degrees. You might even need to go up 15 degrees. Once you do that, you're going to want to print yourself a small, flat print. Make sure you have good bed adhesion. Rich will tell you to print a temperature tower, which isn't a bad idea. My biggest issue with ASA is first layer adhesion to the bed. So do yourself a print, let it cool, take a look at the bottom of it, see if you have any warping at all happening on your ASA. If you do, I would do one odd thing and one normal thing. The one normal thing I would do is I'd raise your bed temperature again, maybe 3 to 5 degrees, depending on how high you want to go. The other thing I would do is I would then lower your print temperature by a couple of degrees. That way the difference between your bed temperature and your print temperature are closer. There's less shock to that first layer of plastic. Once you get to a point where you think that first layer's adhesion is pretty good, that's a hard word to say, then work on a print. Maybe do yourself a calibration cube or something like that. And when you do that calibration cube, do a relatively high infill, because the more infill you have on a part, the more pressure there is on the inside of it to warp it up. And then once you have something you think you can work with, actually do your parts. But in a nutshell, ASA is a great filament. It will hold up a little bit better in terms of temperatures, and definitely a lot better outdoors. But a lot of people seem to be kind of venturing into ASA right now, and I figured I'd give you a couple tips I found while working with it. Let's see here. SK3D, how are we doing today, my friend? You're down there somewhere, so let's see, where are you? There's Golden Jaguar, there's, yeah, I left to right, right to left, right? You're down there. So anyways, so ASA, ABS, that talk about quick. Brands, let's talk about brands real quick. If you're looking for inexpensive brands on ABS, if you can find Amazon Basics ABS, it seems to work really well for me. Now keep in mind, most of the raw materials that come from 1 or 2 major manufacturers worldwide, it all comes into what gets mixed into those raw materials to make them what they are. But Amazon Basics seems to work pretty well for me, although I think they just continue making it. Outside of that, I'm a big fan of Polymaker, the Poly Light series, as well as, let's see, for PLA, Polyterra works pretty well. But all in all, Polymaker makes a pretty good product. If you're in Canada or you're looking for something that maybe has some sparkle or something to it, I really do like the ABS Plus Sparkle from Sparta 3D. That's really good. And the other thing that actually I didn't do on purpose, but is kind of happening, and I don't know, by all means, leave me a comment if you got any information on this in the chat. But it looks like the higher end manufacturers of filament are starting to go with the cardboard spools. So all these right here are all cardboard spools, which is actually really nice, because where I live, you can't recycle a plastic unless it has one of those little numbers on it. And then again, they only recycle certain numbers, not all of them. So having cardboard spools is a nice feature. I don't know if it costs more or less to do that, but that's pretty cool. Look at the chat real quick, see what's going on. Plastic pushing friends. That makes us sound like we're trying to force people to print. But I get it, that's cool. And let's see here, Amazon Base is good, as well as Matter Hackers. Yes, Matter Hackers is good. Actually, since we're talking about Matter Hackers and ABS, another one that I've had relatively good luck with and it's probably a little bit lower down on that chain, is the eSun. eSun works pretty well. There's one brand that I will not use, but I'm not even going to talk about it today. There's one brand I won't use. And I have some random other brands around here too that I haven't had issues with. Because again, like I said, all these companies that are making all these filaments, they're not really making their own filaments. For the most part, and actually Rich probably knows more about this than anybody else on this chat, but your raw materials are coming from a couple major manufacturers worldwide. Then they go into basically manufacturers of the actual filament, and then they get distributed out. You can buy white box filaments, what basically happens, and that's kind of what happens with Amazon. They're buying what you'd call a white box filament, which is a filament that's non-branded, but it's manufactured. It also makes other filaments. So the whole root of the whole story is, if you find a filament you like, stick with it. Let's see. ABS is good too. Let's see, have good luck with Polymaker. Yes, I agree. Polymaker is awesome. I need more Polymaker. Let's see. In Europe, Extruder, Redline, Filamentium are good brands. Awesome. Good to hear. Good to put it up there. So Alex S is saying in Europe, Extruder with an R at the end, no ER. Redline and Filamentum are good brands. Alex, I assume when you say it, you're talking about across the board. Are we talking about ABS or PLA? Let me know and I'll chat it up here so people know. See, I'm printing with Sparkle ABS right now. Steven, what color are you printing with? I am a big fan of the Sparta. I have probably about 4, 5 different colors of the Sparta ABS. I ordered it in bulk because the shipping was almost as much as the actual filament. So, yeah, anyways. All right, so while we're on that filament kick, actually that's ABS, I don't want that one. I want to talk about polycarbonate. I was talking to Rich today, and Rich has been around a long time. I mean, the guy's got tens of thousands of subscribers on his YouTube channel. He's got hundreds upon hundreds of videos. He's got thousands of hours worth of videos, I would assume, give or take. And he's been doing a lot of things, but one thing he hasn't done is printed with polycarbonate. So I printed with polycarbonate in the past, and I plan on doing so again quite soon. Actually, as soon as this new Voron is all done, that's one of the things I want to do some printing on. I'm actually going to do some testing between polycarbonate versus ASA versus ABS when it comes to printed parts, deflection, bending, temperature resistance. So I'll tell you a little bit of what I know about polycarbonate and why it's a good print filament to use, and I will tell you why it's not a good print filament to use, and you can judge your use case based on that. Let's see. Galaxy Black and Sky Blue, Steven says, for his Sparta. All kinds of materials, Alex says, for the European filaments, which is good. That makes sense. If a company makes a good filament, they tend to make multiple good filaments. Obsidian Black. Yes. Okay, so let's talk about that real quick. That one caught me really, was the Obsidian and the Galaxy Black. So I'm glad you mentioned that, Steven. Steven, you prefer Steve or Steven, Steve? So Sparta 3D makes a Galaxy Black Sparkle, which is this guy, and they make a, actually, Obsidian and a Galaxy Black Sparkle. And on their website, and probably in this video right now, you would be hard-pressed to tell what the difference is between the two. It's just hard to tell on video and in the pictures they give you. But I will tell you that when you print with, and I think I have a part right here. Let me grab another part. Well, that worked good. When you print with Sparta, Obsidian Black, which is this, and Galaxy Black, which isn't going to focus for me, and you put them next to each other, and let's see if I can get this to focus. Oh, you get to watch me juggle plastic. See if we get that to focus. You'll find that the Galaxy Black is more of a brown. So if you're looking for kind of a deep, like a dark chocolate brown, that Galaxy Black is what you want. I wrote to Sparta and told them that they shouldn't call it Galaxy Black, they should call it Galaxy Brown. I think they laughed at me and then went on to the next email. But I do like their products. Their customer service has been pretty good. They haven't done anything to really put me off at all. And that's just an opinion on the colors. So, sky blue. So I don't have a sky blue. I have, what is this? Fluorescent blue. That is what I'm using on my current 2.4 is the obsidian in the fluorescent blue, along with some of the lime bot green. So I have two accent colors on my current printer build. Obsidian. I like carbon fiber, PTG, ABS, good for stuff. Yes. Steven, perfect. I will refer to Steven as Steven. All right, so back to where I was on my thought, and that is on the polycarbonate. So polycarbonate is relatively difficult to print. And before you even get out of the packaging, probably the first thing you need to know is it needs to be kept in a dry box. Polycarbonate will absorb water about like a sponge. And once it does, it will not print well at all. So if you live in a very humid climate, you want to keep your polycarbonate definitely in a dry box. And only take it out when you're going to be using it. Preferably you'd have a dry box that would allow you to feed the polycarbonate into the printer. Something like, bear with me here, something like a Sunlu or similar, basically a dry box, has a feed through on it. So your path to the printer, basically the only thing that's going to be exposed, and these are inexpensive. You can buy really expensive options that will, they have Bowden tubes that come off of them all the way, go all the way to the printer. But these you can get for relatively cheap. This particular model has a heater all the way around it, which is nice. This one's made by Sunlu, but there are other companies that make the same thing. But when you have polycarbonate, you definitely want something like that if you're in a humid climate. So that's the first thing. Second thing, well, let's see. Nobody's saying much, okay. Second thing I would talk about with polycarbonate specifically is temperatures. So this polycarbonate on the packaging says the hot end needs to be between 235 and 260. So that means if you're using a Ender 3 or an Ender 5 or another printer that does not have an all metal hot end, but it has a PTFE tube that goes down into it and meets up with your heat break, as opposed to being metal all the way down through, you're going to get to the point where you're starting to bake that PTFE Bowden tube that goes down in there, and that is not good. So you don't want to do that. So you want to make sure you have a all metal hot end when you work with polycarbonate. On top of that, you're going to want a hot end that can maintain those temperatures. I think probably around 250, and that's usually where I would start with something like that, is I start towards the high end of whatever the manufacturer suggests, back down maybe, 5 or so degrees, and then you have some room to play with. I like to print most of my filaments hot, as opposed to on the cooler side, unless we're having bed adhesion issues. And the reason for that is because you get better layer adhesion from your prints. Usually layer adhesion is one of the things that you can easily manipulate by the temperature you print at, along with your part cooling fan. So along with that, you also need a bed that can go between 70 and 100 degrees with this particular brand. And I will tell you that 70 sounds awful low for polycarbonate. I don't think I've ever successfully printed polycarbonate with anything under 90 degrees Celsius. And 90 degrees requires for me at least, let's see if I can find it real quick. I don't think I can. But polycarbonate for me, when I'm printing at a lower temperature, requires me to basically manufacture my own bed. This is the cutest little bed you've ever seen. But manufacture your own little bed. The way I do that, the way I've done that in the past, is simply go down to your local Home Depot, Lowe's, Menard, whatever you have in the Europe or in Canada that sells home building supplies and things like that, and get yourself a sheet of polycarbonate. So basically buy yourself a small piece of polycarbonate. You can get them about 3/16 of an inch and a little bit thicker than that. buy your piece. You might have to cut it a little bit down the size to fit your bed. The way you can do that is the same type of tool you use to cut glass, and you put it on a sharp edge and you can break it, or you can use a saw if if you have a saw that you can cut it with. Take the surface of it, clean up 100% both sides, rough up the side of it with an emery cloth or with a piece of Brillo or Scotch-Brite or something like that. Clean it off with your ISO 100%, clamp it down to your bed, let it heat up, and then you're basically printing on polycarbonate with your polycarbonate. If that doesn't get you adhesion, nothing will. So that's kind of the trick I use when I print polycarbonate on my Ender 5, just because I couldn't really get to those high temperatures I needed. So if you are interested in printing polycarbonate on a slightly lesser of a printer that's not able to get to that 100-degree bed temperature, that's a good way around that. So chat's pretty quiet. Anybody out there have any questions or concerns or issues with filament currently? Just let me know. You holler them out. If you have questions about my current build, holler that out. This is kind of a chill and chat session here, and it's kind of a viewer run show. So whoever's here is whoever's here, and we all get to be part of it. So I will continue on with other stuff I have. Let's see. SK3D. Does anyone have an example of print start macro that works well with the Voron tap? I have issues with the first layer now, and I'm using the Auto Z config. So SK3D, if you're good with it, if anybody here, because I haven't done my tap yet, but if anybody here does have something and you want to email it to me, I would be happy to get that to SK3D. Or if you have, kind of hard, nobody can really post a link or anything on here, but if you have information, let me know and I will make sure that that information gets to SK3D. Again, my email is around the channel, or if you want, it's Kerm, K-E-R-M, at builditbasement.com. If you email me something, I'll make sure you get it. Yeah, that'd be great. I appreciate it. SK3D would appreciate it. So let's be a community, help each other out, right? Let's see here. What toolhead board are you using? Are you talking SK3D, Woody, I assume? Yeah, anyways, you guys carry on with that. What else I have? I also want to talk today. I want to slow down a little bit actually first. Little jitters here. I don't do a lot of live streaming. SK3D says he's got the stealth burner board. Using the next question is going to be a one-piece or a two-piece board from Woody, I assume, but it shouldn't make that much of a difference either way on any of those things. So, something I got in the mail. So I received this week. Oh, what board is? Let's see. What toolhead board are you using? Oh, I am using on mine a, is it the Lineo? You know, you had to ask me that. It's been in there for a minute. Let me switch cameras so you guys can see what I'm doing. I need to look, because I honestly get multiple parts for a lot of things, and then I choose what I want to use. But this is the board from Lineo. I'm using a Lineo version of the Stealth Burner board specifically. Didn't think it was the LDO board. Yeah, the board in my print head is an is not an LDO board. It is a Lineo board. The one that comes with the printer from LDO is a little different. This one's a little bit upgraded, we'll say. It's not needed. You don't need to buy it, but you do have it. Yeah, so why do you ask, Woody? Just wondering. What's the deal? Do you plan on putting filament runout detector? It's a good question. I have, if I can find it, I have indeed Filament runout sensors are relatively easy to make yourself, but they're also relatively cheap to buy from a company like Big Tree Tech. So I have the, we're going to talk about that, Rich, the V0 versus V2. It's almost like you knew I had two printers here, right? So this is the smart filament sensor from Big Tree Tech. And basically on the bottom here, you have your connector on there, a little connector on the bottom there. And then you have your filament, which is probably just a micro switch that the filament goes by and kind of knocks over. When it goes away, opens the circuit, allows you to know. But I do plan on putting this in. And then the next question it's probably going to have is where is it going to go? Just because of the way my printer's set up, I plan on putting my filament runout sensor on the back side of the printer. So if there's a break in my filament inside the printer in the Bowden tube that goes from, from the outside to the inside, it will not detect that. But those situations are relatively rare if your printer's properly set up and working proper. So it's going to go on the back side because it is relatively large. Hold up my hand. It's not a tiny thing. You can and possibly should, if you want to try it, build a filament runout sensor that can go around top of your stealth burner or afterburner. And again, all you really need for a filament runout sensor is a micro switch that gets depressed when the filament goes by it, and then when the filament stops going by it, it stops depressing that micro switch. It can be fiddly, but it's not a really complicated thing to manufacture yourself if you were into doing that. So it might be a good thing. It's definitely a good little upgrade to do that you could easily do without buying more than, say, $1 or $2 in parts. Or you can buy a pre-made one and complain if it doesn't work. Let's see, advantages. Putting film right down the back. Electronics bay. So yes, the wiring for the filament runout sensor, which is 4 wires. Actually, is it 4 wires? Why would it take 4 wires? I think it's just 4 wires to the board. It's actually just a closure, so you could do it with 2. Yeah, so that is going to run down on the back side of the board, back side of the printer, the very rear of the printer. Let me take a look at this real quick, since it shows up on camera. So turn this a little bit. So this is the rear of the printer right here, and picture panel here. On the back side of it, you have either your Nevermore Max on it, if you had that, or you have your small air filter with your filament coming in here. It's gonna be right here. Wiring for that, it's probably gonna get dropped down near one of these edges right here. I might build or somehow make a channel guide or something to put over those, so the wires aren't just exposed. But that's pretty much where it's gonna go on the back. It's pretty simple, not too much of a complication. It's one of those things that you could definitely make more complicated than you need to. Yeah, and then right into the electronics bay. Yep. If you wanted to, you could probably drop it down and then bring it. If you manipulate your back panel a little bit, you can bring it in and then actually drop it the same place that your Z drag chain is coming in. So I'm gonna set this back to where it was, and I'm gonna get to Rich's question, which was an obvious one based on what I have sitting in front of me today. And that question being benefits of building a Voron 0 versus a Voron 2. And to do that, let me switch over to this real quick. So right here in front of us, me, you, slightly different but the same, right? I have a Voron 2 and I have a Voron 0. And neither one of them are in focus, but we don't have to have them in focus. Just to show you what the scale size difference is, a Voron 0 can fit inside of a Voron 2 pretty easily. There we go. So Voron 0 inside of a Voron 2.4. So you're definitely talking about two completely different scales of printers here. And then one of them, the reason why I want to talk about this is one of them I find to be a lot easier to build than the other one. And it might be kind of surprising, for one, which one is which. And then for two, why which one is which. So the Voron 0 printer is almost a completely different setup in terms of the Z. The Z on a Voron 0 printer is a lead screw driven printer as opposed to a belt driven printer. It has a single lead screw, and they get away with that just because this bed's only about 120 by 120 millimeters. That. So it's a pretty small bed. Lead screws tend to be a little bit more exact, meaning that you can basically have smaller micro steps with lead screws because they're just easier to have more exact. It does use still a Core XY system on top here. I don't know why it's not focusing. Why isn't that focusing? There we go. I think it stayed in focus. It does have a Core XY system for your X and Y, which is nice. It's very similar to what's on the Voron 2.4, but not exactly. It's definitely scaled down quite a bit. The rest of the printer is pretty interesting. Time to build a Voron 0 is going to be roughly half to 2/3 of what it takes to build a 2.4. Cost to build a Voron 0 is again going to be roughly 2/3 what it costs to make a 2.4. And when I say that, I'm talking about equally equipped, because you still get to choose your hot end, you know, what kind of controller board you put inside there, whether or not you buy the super uber good part cooling fans and hot end cooling fan, and some other things like that. You know, if you buy the actual Bondtech gears versus not, things like that. Let's see here. Hey all, hey go. So Tesla just joined up. Hey man, what's up? Ain't it cute? It is cute. It's cute and it's fun. No damn notification. Yeah, so not to get off track too far on that, YouTube, even if you're signed up for notifications, doesn't necessarily send out notifications. What they're doing now is they're basing it off of how many viewers are actually on a stream. So if the stream doesn't have a ton of people watching for whatever reason, because people are busy or whatever, you may not get a notification for it. So thank you, YouTube. Okay, back to the cuteness of the Voron 0, as Woody had stated. So 120 by 120 bed, which seems awful small, especially when you compare it to the bed size on the Voron 2. You could probably fit close to 6 of these beds on here in total volume, or I guess square inches, square millimeters, square centimeters, whatever you're using. On top of that, the bed on a Voron 2.4 is a fixed bed. You can have a Kinematics system like this one has here, but it's basically a fixed bed. You don't make adjustments to the bed itself. Your adjustments come from your gantry, which leads to a second level of complication when it comes to software. On a Voron 0, your bed is adjusted by screws and springs. This is very common, and it's been hugely common since pretty much the beginning. There are a couple of benefits of using screws and springs. One is that if you do crash your nozzle, there's some give. That one's something that people don't normally even think about. But when you crash a nozzle on a spring-leveled bed, it will depress somewhat. Not saying that will save you, but it will, you know, definitely do that. Two is it makes adjustments really quick. And that's kind of a biased statement, because on a 2.4, if it's set up properly and the software is running properly, you really don't need to make those adjustments very often, if at all. On a 0, you will have to make adjustments to those screws depending on possibly the type of filament you're using or just time, because the screws tend to heat up, contract, things happen. So biggest changes between these two is a lead screw for a drive, spring-loaded bed, smaller size, obviously. It's pretty damn cute, as Woody said. The rest of it is pretty similar to a Voron with a couple of exceptions. And I'm going to talk about the build a little bit here. So the build on a Voron 0, if you're thinking about doing a Voron 0 versus a 2.4, I would say it's slightly more difficult. And the reason I say it's slightly more difficult is you're going to go nuts putting nuts in the channels on this printer when you're building it. Everything on this printer is pretty much held together with 3mm nuts that you slide inside of the rails. And that's not, I mean, that's a real pain in the rear end, to be honest, because there are hundreds. I didn't count them, but I'm guessing there's probably 130 to 180 of them. On top of that is, because of the way the printer is put together, the nuts that go in, once you attach another extrusion to one of the extrusions you're working on, you may no longer be able to put a nut inside that extrusion. So if you miss a nut, that means you're tearing apart a good portion of the printer to get back to it, which could make you cry if you forget too many. I don't know if it's in the build manual, but there's a lot of suggestion that when you build a Voron Zero that you put additional nuts in case you want to put accessories on it. And I would totally agree with that. I'm looking at it right now and I can see 6 additional nuts I have currently on this printer. So outside of that, it's a decent little printer. The bed's super tiny, so it heats up super quick. Because of the low amount of mass here in the print head, in the X gantry here, it will print super fast if you want it to. It's all dependent on how hard you can push your hot end. But it's a really decent printer for one, printing repair parts or printing little tchotchkes or trinkets and things like that. I was talking with, I think it was a Snowman 404 on the First Layer Discord, and he's actually printing all of his Voron 2.4 parts on a Voron Zero, which is quite the undertaking. So on the back here of a Voron Zero, this is where your electronics mainly are. There's also some electronics on the bottom side, but you have your controller board, which is a little bit more simplified compared to what's on the 2.4, just because you don't need as many steppers on it. You have Raspberry Pi, if you go with that combination. Some of the wiring here, and then finally you have your 120 volts slash 220, whatever you have, depending on what country you're in, on the bottom side. And there are panels to put on this to cover these all up. I just have chosen not to at this point. I probably should. I've also never put the top hat or any of the other stuff on this. This is kind of a fun printer. Definitely portable, really portable. I've taken this to work just for fun, print off a couple things. It's a good printer for kids. If you have kids that want to print little things, because the wait time for the bed to heat up and everything are really minimal. So that's really good on that one. You guys throw some stuff in the chat if you have questions about what I'm talking about, or if you have other questions not specifically related to what I'm talking about. So I'm just going to keep babbling on. 2.4, let's talk about that real quick, and let's compare the two now that I've talked all about the V0. If you've been watching my build series on this 2.4, or if you watched my old build series on my old 2.4 non-R2 version, this is a big build. It's not the biggest printer you can build by any means. You can get a rat rig 500 by 500, which is almost double the size of this, and in volume it is double the size pretty much on the internal volume. It's a big printer, but that doesn't make it a confusing, complicated, or otherwise difficult build. Again, when I talk about build between these two printers, I would say that the Voron Zero actually has a little bit more of a difficult build than the 2.4, which might not be a popular statement, but I stand by it, and it has to do specifically with putting the nuts inside this thing. It's just a real pain. This, on the other hand, can use hammer nuts or T-nuts, basically slot nuts that go inside of the extrusions. Allows you to basically not have to, or forego completely the issue of not having to place your nuts inside the extrusions before you build, which is really nice. On top of that, everything on this printer is larger. So if you are a normal sized human being, meaning if you are between, say, 4'6" and 6'6", your hands are going to have difficult time doing some of the things that you need to do on this printer, just because of the size of it. Whereas on this printer, everything's a little bit more open. You can kind of see everything. It makes it a little bit easier to work on. That being said, I would say that the 2.4, R2 or otherwise, probably has a larger fan base. This is not the newest Voron printer, which is another thing that happened, or a lot of people were thinking probably for the past couple of years, is that the Voron 2.4 was one of the newer Vorons, when in actuality this is kind of one of their older designs. That being said, it's also one of their refined designs that has gone through, you know, some revisions and some changes. Also has a huge amount of following in it, a huge amount of modifications available for it. Not to say that the Voron Zero doesn't have modifications, it definitely does, but the 2.4 has a lot more going for it in terms of that community. That's me, huge hands, Woody says. Yeah, Woody, I wouldn't suggest building a Voron Zero if you have the huge hands. Just like the Voron Zero, the 2.4 comes with, or is built with, a core XY control or drive system for the XY system, meaning that there's two belts that run opposed to each other, so that basically whenever you're making a direct lateral forward or back move, you're actually driving both of your stepper motors. That can help with precision. That also helps with basically just everything being tight where you want it. The only time a Core XY printer in general, whether it be this one or this one, only moves one motor, one stepper motor, and I can just barely do it. I'm trying now. It's actually kind of a skill game. Is if you move your print head at exactly a 45-degree angle in one or the other direction, I can do it like that. So it's an interesting setup. It's kind of like it's not, but it's kind of like an Etch-a-Sketch in terms of if you want to make a line. On an Etch-a-Sketch, you know, you have to turn both knobs to make those lines the way you want them. Outside of that, the build on the 2.4 does have probably almost the same amount of parts, to be honest. Again, with the Zero, you're just dealing with smaller parts than you are with the 2.4. The 2.4 and the Zero both have multiple print heads available, especially now. There is a mini stealth burner available for the Voron Zero, which is kind of a copycat of what's on the 2.4. Trying to think if there's anything else, really. I would probably strongly suggest 2-to-1, a 2.4, and if you were worried about cost and things like that, maybe step it down to a 250, or if you're self-sourcing, you could even go even smaller than that. I probably wouldn't go too much smaller than 250 though. 200 might be the maximum you can get down on that. In terms of size, you wouldn't want to build a Voron Zero bigger than what it is. It's a single lead screw design. It's not meant, because of this cantilever here, to be overly big. The longer you go, the bigger the bed you get with a cantilever design on a single lead screw, the more issues you're going to have. If you did want to make this, there are other printers, either from Voron or other entities out there that have duplicate lead screws that allow things to get driven at the same time, if you want a bigger bed than that. Let's see here. Yeah, so cost-wise, you know, like I said, 2/3 versus a full. Go smaller with your Voron if it's your first build is probably a good suggestion for that. And then don't cut corners on any of your motion parts. Extrusions, you know, you can get away with buying decent extrusions, not the cheapest you can find, but you don't need to buy the super uber ones. Belts are a arguable point. Most people recommend Gates belts, but pretty much, and Golden Jaguar will say it, any belt that basically has a fiber reinforced mechanism inside of it should be good. And the reason for it is because you just don't want your belts to expand too much. You don't want them to pull and no longer be tight. Let's see, back here to the chat real quick. How tight is the wiring radius in the back of the motor? I'm a little more slack than what I see in yours. Should I tighten it up a bit? Okay, Woody, if you're talking about the AB drive motors specifically and slack, I will tell you first, one, it doesn't matter. It's usually one of my biggest answers to things is it doesn't matter. It's more of an aesthetic thing on this. So all I did was leave what I would call a service loop, even though you don't really need a service loop on these. They are flat with the bottom of the motors, and that's just because when the motors do come down, when you're at your maximum or minimum Z height, which on this printer it's probably gonna be right about there, you still have plenty of room right here. So that wire can be down a little bit, but keeping it up just makes it nice and neat. In terms of the rest of the slack, I just keep the wires so they don't get tangled up in anything. That's pretty much what it comes down to. Main wiring harness where it bends into the chain. Oh, over here on this side. Let me pull it. We're talking about on the X or on the back side right here. So on the actual gantry, no, on the back. Okay, on the very back, you're talking about it coming down from the top of the rail into the chain, I assume. Backside fast turning point. Okay, so obviously on the swoop here, okay, wow, that low latency is working pretty well. This is almost real time. I'm kind of surprised. On this right here, obviously you're kind of formed a swoop that's designated by this piece right here, this cover plate. On this part right here, you're not. And I would keep it relatively tight. And the reason why is there's no reason not to. This part actually isn't going to move much. This wiring down here isn't going to move much. Most of your wire movement is inside your chain itself. If you have an excess of wiring here, there's a slight chance at some point when your tool head, whoops, I gotta go up a little bit because I'm hitting my brush. There's a slight chance that when your tool head comes back, you could come near something. It's not very likely, but I guess if you had enough slack there, that could happen. I would say for a radius, I am up against the plastic without being, you know, not creasing into anything. So my radius, if I had to actually tell you what my radius was, it's about the size of a $50 or a loonie if you're in Canada. And if you're not in either one of those, I'd say it's about 3.5 or so centimeters. Yeah, line it up there, Woody. Let's see. I'm not swoof, I'm back. I'm too slack there. I'll tighten it up a bit. Yep. Okay, no worries. Awesome. Again, people will tell you this all the time. This is a printer that you're building, so it's your printer. It's not just any printer. Everybody's printer is going to be a little bit different. If there was a perfect way to do it, the manual would be way more in depth. Not that the manual shouldn't be more in depth or not. Yeah. Anyways, let's see. SK3D. I have the same hands, same huge hands issue as Woody. Yeah. Yeah, so a Voron Zero is not an easy build by any mean. Looney, how dare you call us Looney? I call you a toonie too. You go upstairs, I probably have some Canadian money. Bye guys. Hey, Golden Jaguar, thank you for the stream, Kermit. Thanks for support. Should be going back to work. See you next stream. Going to work out. Okay, awesome, man. Yeah, hope you're doing good. Hope everything's working out for you. Yeah, I'll definitely check you soon. Maybe I'll see you on the Discord. Wonderful to have great examples go by. Yes, yeah. Let's see here later. Yep. All right. Yep. So that is kind of that on the 2.4 versus the 1.0 in terms of build. I have not built a Trident. I am interested in building a Trident. When I talked earlier about having a printer with double lead screws, I was kind of referring to a Trident. You know, there's pretty much only two ways that I'm aware of for a Z drive to work on a printer, and that's either a lead screw or belted. Belted tends to get you longer or higher Z on a printer, because the problem with the lead screw is it will wobble the longer they get. On a belted system, you don't have that problem because, you know, gravity. But on a smaller printer, a lead screw, definitely you can get some more precision out of it. One of the things I plan on doing, probably putting a video up about it, is everybody talks about how fast printers print and things like that, but I haven't seen any videos recently about anybody printing with like a very small nozzle, like a 0.2 or even a 0.1. I know I have a 0.2 nozzle. I'm going to try to get myself a 0.1 nozzle. And then on this little tiny guy right here, do some 0.1 printing on it at high speed and see how nice we can get things. See if we get anything that approaches, you know, some of the resin printers. So let me switch this camera over to here. There we go. And I'm gonna try to look through this chat a little bit. I'll move the camera back a little bit again. Can you explain the 3-point bed on your Voron 2.4? Great question, Rich. And you asked it right after I got out of that printer. So I will do it without the printer because I can. So a 3-point mounting system on a printer is called a Kinematics mounting system. And usually what happens is you have a ball and socket scenario where these would be the balls on the print bed. And then on the printer itself, trying to move stuff around a little bit, you have some type of sockets. Actually, I go this print. There we go. All right. So you have some type of sockets. Now those sockets come in multiple flavors. And that's kind of an interesting thing because different manufacturers of kinematic systems do it differently. On this Mandela Rose kinematic system, there are 3 different types of mounts. There is a flat mount right here, which is just a neodymium magnet that's sandwiched here so it doesn't move, but you have a wide surface. It's probably about 1.5 centimeters or so in diameter. And then back here you have another neodymium magnet that has a concave hole dug out of it so that the ball fits near center. I think you can, yeah, you can just barely see that right there. And then last but not least, you have a roller pin style mount right here so that the bed can slide left and right, but not so much front to back. So between these 3 different points, you have availability for that bed when it's expanding or contracting to basically move left or right, to rotate, and to move in any direction it wants. So because you have 3 points like a tripod, it keeps the bed flat on the surface, but at the same time it allows the bed to have some movement when it comes to that expansion contraction of the printer when it heats up. So the primary benefit of having that system in place, because you might be asking yourself, why does the bed need to move at all, is because things that don't bend break. And steel, although it's very hard, bends. It doesn't snap usually. There's always exceptions to those rules, but because steel will bend before it snaps, what will happen is you'll wind up with bed taco or something like that because of compression points. And that will actually lead me into another topic. Thanks, Rich, for this. Because compression points or expansion points you have on a piece of metal where it's basically forcing itself against something or opposing or to something, something's going to give. You know what I mean? That old adage, if it doesn't bend, it doesn't break, or something's going to give. It's basically what's going to happen is your points, if your metal's expanding and you have concrete points that are set right there, it can't expand in one direction, so it's going to bubble up. Kind of like if a car gets dented. Yeah, if you ever seen anybody do one of those paintless dent removals, you'll notice that there's 2 ways of doing that. One is they pound it from the back, which is the quick, cheap way of doing it. But the other guys that do it, they actually work their way around the outside of those dents and pull those ripples up. And the way that they do that is because when you dent a piece of metal, it has to go somewhere. It doesn't just dissipate directly where it is. It goes someplace else. So when you have a 3-point bed mount in a kinematic system, it allows that bed to basically move all at the same time in the directions it needs to move, as opposed to only having set points that can move, which causes things to warp. That being said, let's get back to this real quick, because just like Rich, he opened a can of worms. Along with the Kinematics bed mounting system that's on this printer, I also have the backers on this printer. These are the Y backers. This one's hard to see because the drag chain's over it, but there's one on each side here. There's also one on the back side here on my gantry, on my X. So what happens here is on the bottom side of here, we have our linear rails, which are made out of kind of a hardened steel. I don't recall exactly what type of steel, but it's a hardened steel. And our extrusions are made of aluminum. And this is on all 3, obviously, because we have, you know, we have things sliding here. So because of the differences in the metal, it's called a bimetal effect. It's also how thermostats work as well in a lot of places where they don't you know, they don't, actually older thermostats where they use a piece of metal that has one type of metal on one side, another type of metal on the other side, it will curl. So basically the reason why we have backers here, they're opposite of the linear rail that's on there. So the steel is going to expand and contract at a different rate than the aluminum. And because of that, when the steel expands or contracts, it's going to bend this aluminum extrusion. So the backer, this is made of titanium, which is a very strong metal, and has a more similar expansion and contraction to the aluminum than it does to the steel, holds this aluminum in place a little bit better. And the reason why it's on the opposite side is it's not actually stopping the force from bending this, bowing this way. It's stopping it from expanding and contraction this way. The reason why I'm mentioning that is logically, to me, originally, is if we're trying to stop it from bowing like this, arching this way, or on the opposite side, we should be using the thick point of this titanium backer on the side because that's where the most strength is. But after a conversation with Whooping, who's on the dev team, who explained to me that the design of the backers isn't necessarily to stop that from happening using the thickness of the backer, but to actually, with every single one of these screws, and this is why there's this many screws in this backer, is basically to stop it from expanding and contraction directly onto the piece of metal, not necessarily stopping the bowing once it starts happening, but to stop it before it even expands and contracts. So when you do put on your, if you do backers, make sure you put in all the screws. There's going to be more screws in your backer than there is actually in your linear rails. So just like we had with the Kinematics bed system, for the expansion and contraction, we also have to deal with that with our extrusions. All right, let's see here. Okay, so that pretty much in a nutshell is what Kinematics does for us, how it helps us. Also is how the titanium backers work on this particular printer. One thing I didn't show when I was on the printer is the reason I was printing ASA was my purge bucket here. ASA will buy you about another 10 or 15 degrees in temperature versus ABS when it comes to deformation. So you got that to go with. Anything else you want to poke and prod me on, Richard, just so I can throw it out to everybody else? You seem to be pretty good at that. Or Woody, anything from you? SK, anything? More than happy to answer questions. If not, I'm going to talk a little bit about this thing I got in the mail from Big Tree. It's pretty quiet. It's a lazy Saturday afternoon. I didn't wear my sunglasses. I'll tell you right now, I'm working on not only getting my videos out there now that I got this new PC set up, but I'm also working on my graphics, my transitions, my overall appearance, trying to make it a little bit more pleasurable for people to watch. Also change the music in the background a little bit to make it a little bit less nervy, if you will. So if you have comments or anything about any of that stuff, more than willing to listen and hear about it and modify as needed. All right, well, so in the mail, I received, and I did not pay for, I'll tell you that right up front, Big Tree Tech EBB SB2209 CAN interface. So that goes along with the other CAN interfaces I have here to test with. And if you're not aware, I plan on upgrading my 2.4 to a 2.4 R2. And the reason I'm doing it is because I also want to go over the maintenance of a printer that's been in use for a year or so. So it's going to be a good opportunity to work on that printer. Once I get to the point where I'm doing the maintenance on it and we're doing the rebuild on it, I also want to do some upgrades on that I'm not necessarily doing on this new printer, but they are going to be on the older printer. One of those things is a CAN interface. So just quickly, CAN, centralist homing. Trying to think if there's anything else. It's going to get a tap just like this one is. I might, instead of doing an opto tap, I might try doing the clicky tap modification just to see how those two compare. I want to have basically two printers I can compare and contrast when it comes to the print speeds, you know, overall quality of print, things like that, different hot ends between them, This one's running a Rapido. I think in the other one, I will either put well, right now it's running a Slice Engineering Mosquito. Maybe I'll put a Mosquito back in it, or maybe I'll put something else in it. My little Voron Zero here is running a Revo, and I can definitely max that out pretty quickly. That's actually the only issue I have with the Revo, is it does max out a lot quicker than I thought it would. Let's see here. Sunday morning here. You're ahead of me. Got that. I thought tap wasn't advised for kinematic beds. Oh, so tap is, it's not that it's not advised for kinematic beds, and I will show you. Let me put this bed back on here. Tap will work just fine on a kinematic bed with a couple of caveats. So, get out of the way again. There it is with tap, and I will tell you right up front that I can make it do that. But tap isn't going to be putting that much force on it. I forget what it is. It's something like 30 grams worth of force to make this do that. It's very little. So for the most part, tap will work just fine all over this bed with minimal issue. The only place on this bed where there seems to be a slight, or I'm concerned about it, is on the front right corner. That takes the least amount of pressure to make the bed do some wobbling, which is not what we want. Like I said, I can do it anyplace else, but when you get to this front right corner, there are issues. At least there could be issues. I've been told both by the manufacturer of the Kinematics system and by KB3D and some other sources that it shouldn't be an issue on a 300. Mandela Roseworks, who manufactures this particular kit, actually makes, I don't remember, different people have different names for them, but they make this thing like these outriggers. I don't know if anybody's mentioning it here. We'll take a look. Find what Mandela Rose, I can tell you that works on. Yep, okay. Bought the outriggers, but they're not being used. Yep. So you can buy the outriggers that go on the back here that basically extend these points, these rear points, a little bit further outwards. You could actually do that on your own without buying your outriggers. You could easily put some extrusion on the sides here, out here, through here, attach them to this point, attach them to that point, be good. The other thing that I thought about that you would have to do a little bit more manipulation, but you could actually widen out your bed mounts, period. So basically if you move these out each, like 3 centimeters or so on both sides, you would definitely widen out your kinematics system there, and that'd be less of an issue. Now that being said, with all of that stuff, the one printer size on 2.4 that I am told is an issue is if you're building a 250 millimeter version. And it's just because it's smaller and that force is different on that corner when you do that. When you have a 250, just because everything's a little bit closer together, outriggers are definitely recognized as being something you should have on that. On a 300 and 350, I'm told that you do not need them, and it works just fine. And SK3D agrees, he's using them right now. Yep, isn't a problem with 350 either. Totally agree with that. So 300 and 350 should be fine. 250, you might want to think about getting the outriggers. I actually had a conversation with, I believe his name was Dave, the gentleman that runs Mandela Roseworks. And that conversation was pretty much, hey, I'm building a printer live on YouTube, and I'm using your Kinematics bed systems. I'm just telling you this so you know that he had the opportunity to tell me, yeah, you should probably get it. I'm building a printer on YouTube live with your Kinematics system, and I don't want to get to a situation where I'm doing tests on my tap and your bed is getting all flopped around because the Kinematics system doesn't work right. Should I buy your outriggers just to make sure it doesn't happen? And that was when I got that response that shouldn't be a problem with 300 or 350, but on 250, it would definitely be a consideration. So, yeah, the whooping chart, yeah, Kinematics bed mounts include a spring hold down that keeps things pretty stable for the tap. Yep, that's one of the other systems. It's actually, I don't think it's as beautiful as this one. It uses basically a fork looking system. So things are kind of layered and then it's kind of sprung together. I think it probably works just as well, but I really do like the looks of the Mandela system that we have here. So yeah, let me kind of move this a little bit. I want to talk a little bit about CAN, because CAN is another one of those hot topics right now, seemingly with everybody. And it's been a hot topic now for probably a few months at least. And I have not joined that bandwagon yet. I have a lot of people asking me, should they install CAN on their printer as first builders on their first build, right off the bat, so to speak. And my suggestion is no, don't build your printer with CAN if this is your first printer. You've never set up a Clipper, or you've never set up a Voron printer before. The problem I have with CAN in general isn't so much the workings of it, because I do think anytime you can simplify things, it's a good thing. But the problem I have with CAN in general is the fact that you're removing the ability for you to trace issues in a printer if you're not familiar with how the printer works completely. It just adds another level of complexity on figuring out what's going on, what's wrong with everything. I'll see, CAN has been around for many years, and I've been using CAN in my commercial life for over a decade. We use CAN systems for, it's used in industrial systems as well. We use CAN for control of systems over long distances, multiple meters. That's the other reason I think CAN's kind of odd on a printer, because we're talking about maybe a meter or so. I mean, I agree it simplifies the amount of wires you need, since CAN only requires 2. But it's to what extent? Usually when you do that, you're doing it because you're saving costs and improving reliability, because you don't have so much to deal with. But we're not dealing with long distances here. If we had a print farm and they were all CANbus together for some reason, then that could make sense. But on an individual printer running CAN, I'm not 100% sold, but it doesn't mean I won't be. It doesn't mean I won't do it. It just means that the value for cost based on what the outcome is, or what the headaches will be, doesn't quite add up for me just yet. Yep. So let's look real quick at what I got in the mail, since I already mentioned it. So Big Tree Tech sent me over the EBB SB 2209 CAN version 1. And I also have a couple other CAN boards that I'm going to play with. I think I have 3. I have this one. I have, what else do I have? I have the Mellow Fly, and I have some other stuff too. Is that focusing properly? There we go. All right. So this came from Big Tree Tech. Again, they sent it to me for free. I told them that I would do an unboxing. I told them that in the future I would do a configuration setup of this and go over the ins and outs of it. I'm not prepared to do that right now. I am just simply kind of showing you what was in the box. To me right now, the best thing that's in the box is this guy. Gotta love the duckies. So just like any other part you get from Big Tree Tech, it's a little, thank you sticker. You get your ducky, a couple zip ties, a couple of stickers in here. Big Tree Tech, and this Big Tree Tech Clipper sticker, which is interesting. Looks like a high current connector here. Let me zoom in a little bit for you. Ooh, that's the wrong way. So it looks like a high current connector here. For those 2 pins, those are your power pins. And then you have your 2 CAN connections right here on that. So you have that, and on the far end side, you have your green, your white, green and yellow, pardon me, CAN connections, and you have your black and red power connections on there. For that, it's a decent cable. The wiring itself just seems like a standard wiring. It's not silicone, and it's not PTFE or PFAS or whatever those other wires are. So pretty basic cabling there. They probably could have upgraded that a little bit. Just because I got it for free doesn't mean I'm going to speak perfectly highly about it, but I will try to be unbiased. Isn't the board that you specifically designed for the, isn't that the board that is specifically, yes, it is. It is. That's why I said yes. So little package there, came in, heat sink. That's probably for the stepper driver that's in here. First we'll look at the board that goes against the part cooling fan on the back of the stealth burner. So it's coming to us with the connection point to the main board. It's also got header pins, horizontal header pins for our different fans, as well as some other things in here. It's a tack pin. There's a 5-volt pin, a couple ground pins, things like that. There's actually 2 fans there, and then yeah, interesting. It's actually a nice board, very nice, very clean. No flux on there. Has a QC pass sticker, so somebody at least took enough time to put the sticker on it, so hopefully they looked at it. Soldering job looks decent, but I do see a couple of small things there. They don't look shiny. They look kind of they're not crusty, but they look kind of dull, which means that usually the solder wasn't quite warm enough. So, but overall the board looks nice. Let's see here. That back in the package. I'm not sure. Yeah, I guess there are some components on there. Put that back in there. And pull this one out. This is the main board on here. Looks like there are a couple of dip switches on here. There's our high current connector along with the CAN. This also has a USB Type-C connector on it, so this can actually be driven via USB or CANbus. I do know that. We have a decent sized fuse there, which is nice to see actually on the board. That looks pretty good. This looks very clean too. I don't see any excess flux on it, which is nice. It does have, it actually looks really nice. It does have spacers built into this, so actually has metallic spacers on that that are built into the board itself, so that it will clear. Yep. So it will clear your plastic when you're mounting it. That's actually really nice. Didn't expect that. And on this side, looks like gold plating on the high current parts. Also looks like there are, let's see, there's a stepper driver. Looks like there's also a reset button on here, a couple other things, and it looks like there's a accelerometer built into this as well. So you have that going for you. And then let's quickly do this. Indicates dirty joint solder didn't melt fully. Yes, I agree. That or was not hot enough when it went on. Kind of like a cold solder joint. So on the printer itself, this is going to mount. Actually, stand by. I hate leaving the camera, but let me grab my big old bag of spare parts. So on the printer, this is going to be something like this. Like that. And let's see here, do I have... Nope, I don't have the other part, but something like that, and then basically is going to connect to the actual main board like so. And then power wire in CANbus right here, or USB Type-C if you decide to use that. So all in all, it looks like a pretty nice board actually. While I have it out, I am going to quickly let's compare it to the mellow. Seems like thus far every one of these things has some issue of some sort, whether it be overheating, or I think overheating is kind of the biggest one because they're putting the stepper driver for your extruder right on the board. So on the mellow, it's very similar but different. So we have less connection points for items on the FLY mellow, but it looks like we have everything we basically would normally need anyways, but not to the extent that the big tree went. And then on the board itself here, no back spacers. I will say the solder joints look a little bit nicer. I can see where some of the parts were snipped after soldering to reduce the height of the backside, but they are still kind of long, if you ask me. Nice fuse holder here in the back. Good connector. It might actually be the same connector that's on the mellow. Yep, they're using the exact same connector. Probably the same, nope, different USB connector, but the exact same CAN power unit. Same capacitor. There's more in common than there is not in common, but the Big Tree Tech definitely has a lot more to it. And those standoffs actually are one of those things that really, good job. Kudos to them for that. All right. All right, let's see. Drytron, yep. So that's going to be when this is down the road now. It's kind of like a sneak peek type thing, but this is going to be for when this printer will, it's kind of cute having that Voron 0 inside that Voron 2.4. But this is going to be when we're done with this Voron 2.4, it's up and printed, calibrated, working perfectly. We're going to go through printing new parts for the old Voron. What parts are, basically, it's going to be a soup to nuts difference between upgrading a non-R2 version of Voron 2.4 to a 2.4 R2. We'll go over what parts we need to replace. We're also going to be looking at what parts are worn or are in the process of wearing, what they look like after about a year of use. I would say probably relatively normal use, and go over the cleaning and the process that it will take to get that upgraded to where we want. And then once we get to that point, we'll do some upgrades to it, such as a CANbus interface on it, tap of some sort. We'll see how tap goes on this unit, sensorless homing, and probably just all around mess around with it, see what else we can do. Probably really like to start working with some macros on it too. Just kind of a playground, if you will, for the printer. So that was pretty cool. Got that from Big Tree Tech, and I'm sure they'll be looking out for the video of when we do the upgrade on the other printer. So put that all aside. All right, chat's pretty slow this wonderful Saturday afternoon. It's about 5:05. So if anybody has any additional questions, comments, concerns, if we want to talk about what we're having for dinner tonight, or you want to tell me about whatever it is, whatever you're doing, I'm more than willing to listen, answer questions. If you want to throw anything out there, SK3D was looking for a macro earlier, so if you want to scroll up and see what he was looking for specifically, it'd be great. And again, you can, if you want to help him out, because I haven't done mine yet, it's going to be a while, you can send me an email or somehow get a hold of me, and I will get to SK3D. My email address is kerm, K-E-R-M, @builditbasement, all one word, .com, or you can leave me a comment someplace else. I will find it somewhere as long as you get it to me, and I will make sure that SK3D gets a copy of it. All right, Rich, have fun with that. Rich has to go. He has to work on his honey-do list. So don't tell my wife I'm down here right now. I'm supposed to be working on my honey-do list. So as always, all good things must come to an end. And like I said, we're only a couple minutes here to the end of this. But I will be continuing on with my build series for my Voron 2.4 this week. I did that list this morning, yeah. So this week I'll be working on this. We have our gantry all put together. We have our belts all on there. About the only thing left to do is make our interconnections between our breakout board and our actual control board. And then we're going to jump into software. I will tell you right now, and actually while you guys are on here for opinions, I got two routes to go with software. One is I bear it and everybody sees everything real time and sits there and watches things happen in real time, which is going to be embarrassingly horrible because nobody likes watching computer screens for hours. Or I record the videos and I cut them. I actually do some editing, which I don't normally do. I kind of pride myself on the fact that I don't edit things out, but I might do that with software. So if you got an opinion on that, I'd be more than willing to listen to it and hear it. And if you want to let me know, that'd be great. So if you have, in the last couple minutes here, if you want to throw that up, if you have any opinion on that, that'd be great. After that, once we get the software in there, we're going to do our first prints. We're going to do some calibration. We're going to go through the Ellis list, and hopefully by then, Woody and I will have our custom cubes ready, so I can print a custom Build-It Basement cube and a custom Green Hornet cube. Yep, put out both. It'd be fun to watch. Okay. I could do that. Actually, you know what I could do is I record the raw stream. What I'll do, maybe if people want that, I can put out the raw stream, and then I can do an edited, and I'll just call one raw, and I'll call the other one edited, or something like that, if that works. Newbies need everything when it comes to software installation. Software can be a pain. Yes, Tesla, that's exactly why I was suggesting editing on that video. I mean, I've done it 4 or so times before with Clipper from scratch, so it's not the end of the world to do it from scratch, but I think every single time I've done it, there's always some hiccup someplace, whether it be the STM or something needing to get flashed manually, not working with Clipper, or something happening. It's those things that you may not run into, or you may run into when you're doing yours. And sometimes you go down on tangents which have absolutely nothing to do with what people watching having to deal with. So that's the concern there. So it's been a lovely, lovely hour and a half or so. Yeah. I want to again mention the folks down below here. I can't usually get this right, but Golden Jaguar right there, and the other folks are all listed. What do we have there? We have Mark Davis, who I appreciate. Mark Davis is a patron of mine. My channel is now monetized. I didn't turn on Super Chat or anything like that on this particular stream. Eventually, I plan on doing that. That way, if you guys want to do that type of thing, you can. Help with buying tools and stuff like that. SK3D just went by. First Layer, DeWitt 3D, Golden Jaguar, all those guys. I'm reading them off the screen, so I'm not even looking at you. But yeah, anyways, this has been real fun. I really enjoy making videos for everybody. Hopefully you enjoy watching them. I am always willing to take comments, positive, negative, whatever you got. Always working on the next idea of what we're going to do. If you have any type of suggestions, comments on either the current build or where you'd like to see things go, I'm more than willing to listen and chat about it. I answer all emails I get. I answer every comment I get. Sometimes it's only a thumbs up or something like that, but sometimes I only require that. We also have the Discord server. If you haven't joined that, that's the First Layer Discord. You can find that over at the First Layer YouTube channel. It's usually posted over there. It's in all the videos. I didn't post it on this one, but it might be in my channel description. I don't know. But we're usually all over there. So that all being said, I will say have a wonderful rest of your day. If it's Sunday where you are, have a wonderful Sunday. If it's Saturday, which for most of us I think it still is, have a wonderful Saturday. And I will see you in a few days on a video, and really appreciate you guys. Thanks for joining me along for this ride, and I'll see you soon.